Alright, so this is going to be part 2 of arc length problems with parametric equations. Alright, we have our problem up on the board here. Find the arc length of x equals e to the t cosine t, y equals e to the t sine t, and we have our interval from 0 to pi. Alright, now, the first thing we need to do, right, we need to find dx dt and dy dt. Alright, we can do that, I guess, over on the side here. So, dx dt is going to be what? Well, that's just the derivative of this piece right here, right? And we have to just do a little bit of product rule to get that. It's going to be e to the t cosine t minus e to the t sine t. And then we do dy dt. dy dt is going to be, well, the same thing, e to the t sine t, but instead now we're going to have a plus e to the t cosine t. Alright? And now we have our dx dt, we have our dy dt, right? Just a little bit of product rule there. And we can plug that into our equation with our bounds, 0 to pi. So, we now have that the arc length is equal to the integral from 0 to pi, the square root of, well, this is going to be e to the t cosine t minus e to the t sine t squared. And then we're going to have, I should have thought this out better. All right, plus e to the t cosine t plus e to the t sine t, quantity squared, and we have a dt on the outside. All right, so now we need to do a little bit of foiling and get this huge integrand right here. All right, arc length is going to equal to 0, the integral from 0 to pi of the square root of, all right, let's start some foiling. Okay, we get e to the t cosine t, that's going to be multiplied by itself to get e to the 2t cosine squared t. Okay, before we do that middle term, okay, well, we're going to have a e to the t sine t, that's going to be multiplied by itself. Doesn't matter that it's negative, it's just going to become positive. We're going to get e to the 2t sine squared t. And our middle term, well, that's just going to be minus 2, right, because there's going to be 2 of them. It's going to be e to the 2t sine of t cosine of t. Okay. You'll notice we're going to get the exact same thing for this one, but except now this is going to be a plus 2e to the 2t sine t cosine t. All right, so we can write that out. Alright, so what you're immediately going to notice here is that these big things right here, they're going to go away. Alright, and now we're left with something actually fairly easy. Okay, we have e to the 2t, well, actually, we can just combine like terms here. We're going to get 2e to the 2t cosine squared t plus 2e to the 2t sine squared t. And you may be wondering, well, why am I saying that this is easy all of a sudden? This is still disgusting. Well, we can pull out a 2e to the 2t here. And when we do that, we get a 1 on the inside, right? Cosine squared of t plus sine squared of t, that's just going to be 1. So we're left with that the arc length is the integral from 0 to pi, the square root of 2e to the 2t dt. Now this may look impossible as it is, but this is easy because rad 2 can just come right out. All right, so don't overthink things like that, right? Rad 2 can come out, that's a constant, and e to the 2t, well, the square root of that, that's just e to the t. All right, so it's not actually as bad as it looks. Okay, you just kind of got to make that connection. So we get rad 2, the integral from 0 to pi of e to the t dt. Alright, just took that rad 2 out, and the square root of e to the 2t is just e to the t, right? So now we can go on to our integration step. That's just going to be that the arc length equals rad 2 times e to the t evaluated from 0 to pi. There's no dt now. Okay, and we get that our arc length is equal to rad 2 times, which is going to be e to the pi minus 1. That's going to be our answer. So, it started off extremely messy here, right? I mean, lots of writing, but it all ended up simplifying down into the square root of 2, the integral from 0 to pi of e to the t dt, right? And then we got something pretty nice, all right? Decent answer there. All right, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for arc length with parametric equations, in the next video in the series. See you soon.